So in this lecture today we will discuss problems of linear inequalities. So we will solve given linear inequalities subject to given condition. First example, solve 24x less than 100 when 1 x is a natural number, and second x is an integer. So let us discuss solution. First you note that inequality is given 24x less than 100. Inequality is strict inequality. First you observe the inequality. It is strict inequality. Second thing, when you note this basic principle, if you multiply it by negative number, then inequality will change. For example, before solving this inequality, you note this basic principle. We know 2 less than 5. If we multiply it by minus 1, so when we multiply it by minus 1, you can observe between these two minus 2 is greater than. So basic principle is if you multiply it by negative number, inequality will change. Now here 24x less than 100, so divide by 24, which is positive. So if you divide by positive, there is no change in the inequality. So here x is less than 100 by 24. Therefore x is less than, you can use calculator, 100 upon 24, so approximate value is 4.166. this is approximate value. Now we have to write down solution for a natural number x and if x is an integer. So natural number which is less than 4.1666 is, you know, it is 1, 2, 3 and 4. So if x belongs to n, capital N, set of natural number, then solution set is set 1, 2, 3 and 4. These are the natural number which are less than 4.1666. But in the case of integer which are less than 4.166. So you can write all integers which are there are so many here. -5 is possible, -4, -3, -2, -1, 0, 1, 2, 3, 4. All are integers which are less than 4.166. So if x belongs to z, then solution set is there are so many numbers, all we cannot denote, so dash 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 -4, -3, -2, -1, 0, 1, 2, 3 and 4. So this is the solution set in the case of x belongs to z. So here question is over, but if we want to solve same inequality, for x belongs to r, real number, then all real numbers which are less than or equal to 4.166. So you draw the real line. This is -infinity to +infinity. Here 0, 1, 2, approximate 4. So x is less than 4 point here somewhere. So x is less than, say this is the number 4.1666 approximate. Then solution set is x is less than 4 points. So all these real numbers will belongs to the solution. So all these real numbers will belongs to the solution. So in that case solution can be written in the interval form. So if x belongs to r, then solution is -infinity open interval, say on the +infinity or -infinity, always open interval, -infinity to 4.166 open interval. If inequality is slack, for example say x less than or equal to 4.166 and so on, so in that case solution, here you can observe, if inequality is slack inequality, you have to use close interval. So in that case solution is -infinity to 4.166. Here it will be close interval since inequality is slack inequality. So this is solution in the case of set of real number. Let us take another example. Second example, solve the inequality -12x greater than 30 when 1. X is a natural number, and another one is X is an integer. So we have to solve this inequality subject to given two conditions. First, for X is a natural number, and another condition is X is an integer. So let us discuss solution. We have given minus 12x greater than 30. So as we know, if we multiply it by negative number, inequality will change. So first we multiplied by negative number, so 12x less than minus 30. You can observe, when we have multiplied by negative number, inequality is changed. Here minus 12x greater than 30, but if we multiply it by minus 1, inequality will change. So 12x less than minus 30. Now coefficient of x is 12, so we divide throughout by 12. So x is less than minus 30 by 12. So x is less than approximate value. You can use calculator. Minus 30 by 12, so it is minus 2.5. Now we focus on the given condition. First, if x belongs to n, set of natural number, then we know that there is no natural number which is less than minus 2.5, since we know that natural numbers start from 1, 2, 3 and so on. So there is no natural number which is less than minus 2.5. So if x belongs to n, the solution set is, in the first case, the solution set is empty set phi. Now let us focus on second condition. If x is an integer, that means if x belongs to capital Z, set of integer, then we know the integers which are less than minus 2.5. So you can observe all these, there are infinite integers which are less than minus 2.5, minus 6, minus 5, minus 4, minus 3, all are integers which are less than minus 2.5. So if x belongs to Z, the solution integers which are less than minus 2.5, that means minus 3, minus 4, minus 5 and so on. But when we write it into the set form, the solution of the given inequality is there are infinite integers, so all we cannot denote, so we write -6, -5, -4 and -3. So this is the solution set in the case of x belongs to Z. We take next example. Solve 5x minus 3 less than 7 when first one x is an integer and second x is a real number. So let us solve this inequality. Now here two different conditions are given. X is an integer, that means we have to solve for x belongs to Z, capital Z. We know it is a set of integer, and in the second case x is a real number, so we have to solve inequality for x belongs to R. So for x belongs to Z and x belongs to R, we have to solve given inequality. So let us solve given inequality. 5x minus 3 less than 7. Therefore, we add both sides plus 3. Why? We are going to get clear cut inequality for x. So here 5x minus 3. So for minus 3 its additive inverse is plus 3. So throughout we add plus 3. So 5x minus 3 plus 3, we have added both sides plus 3. So you can observe here we have added both sides plus 3. So simplification is 5x less than 7 plus 3 10. So now divide throughout by 5. So x less than 10 by 5, that is x less than 2. So now let us write solution for x belongs to Z. So if x belongs to Z, then solution set is, so we have to write all integers which are less than 2. So you know integers which are less than 2 is 1, 0, -1, -2, and there are infinite number. So in this case solution set is dash dash dash. We can't denote all integer, so we have written dash 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 -3 -2, -1, 0 and 1. So in the case of x belongs to z, this is the solution set. Now consider case 2. If x belongs to R, so all real numbers which are less than 2. So in the case of x belongs to R, we know that solution will be in terms of interval. Real numbers, you draw the real line. Say here, this hollow circle denotes we have to omit 2 since x less than 2. If we want to include 2, then we have to denote by dark circle. If we write this, that means we are taking 2. Here hollow circle indicates that we are omitting 2. So now we draw the real line. So this is minus infinity, this is plus infinity, and x is less than 2. So all real numbers which are less than 2 will belongs to the solution. So you can observe here somewhere there will be 1, 0, -1 and so on. So if x belongs to R, then solution is, if x belongs to R, the solution of, as shown in the figure, given inequality is open interval minus infinity to -2. In the case of, since inequality is strict inequality, so you know it will be in terms of open interval. So this is the solution for x belongs to R. Next example. Solve 3x plus 8, 3x plus 8 greater than 2 when x is an integer and second, x is a real number. So you note that we have to write solution for x is an integer, that means in this case we have to solve for x belongs to z, set of integers. So x belongs to z, and x is a real number, that means we have to solve for x belongs to R. So let us solve given inequality. Solution. We have given 3x plus 8 greater than 2. So we are going to get inequalities for x. So we add both side -8. which is additive inverse of plus 8. So 3x plus 8, we have added both sides, minus 8. You can observe for plus 8, additive inverse is minus 8. So now we simplify. Plus 8 minus 8 cancel. So 3x 2 minus 8 minus 6. Now divide by 3. So x greater than minus 2. Divide by 3, which is coefficient of x. So x is greater than minus 2. So now we have to write solution for x belongs to z. All integers which are greater than minus 2, you know it is minus 1, 0, 1, 2 and so on. So if x belongs to z, the solution of the given inequality is as shown here, minus 1, 0, 1, 2 and so on. Now in the case of x greater than minus 2, real number, say inequality is strict inequality, so we have to omit minus 2, all real numbers which are greater than minus 2. So here there will be minus 1, 0, 1, this is plus infinity, here real line, so this will be minus infinity. When we show graphically in future, solution portion will be denoted by bold line graphically when we solve. So at present, from this so if x belongs to R, so all real numbers which are greater than minus 2 is, the solution is open interval minus 2 to plus infinity. Open interval minus 2 to plus infinity. All real numbers which are greater than minus 2. We take next example. Now instruction is solve the inequalities, solve the following inequalities for only real x. Now we have to solve the following inequality only for real x. 4x plus 3 less than 5x plus 7. So solution, now we have given 4x plus 3 less than 5x plus 7. Therefore, now check this simplification. We transfer this 4x right hand side, so there will be a change in the sign. So 3 less than 5x. Now we have transferred 4x on right hand side, so minus 4x plus 7. Now this we simplify, and on the same time we transfer 7 left hand side, so again it will change the sign. 3 minus 7 less than 5x minus 4x x. So this can be written as, just again you check, 4x plus 3 less than 5x plus 7. Add both side minus 4x. Alternate way to explain this, we are using additive inverse of 4x. Add minus 4x. So plus minus cancel, 3, 5x minus 4x, it is x. Now add additive inverse of 7 both side. So 3 minus 7 x plus 7 minus 7. So minus 4 less than x. So minus 4 less than x. Now again you note that when we write a less than b, or either we can say that a is less than b, or on the same time we can say that b is greater than a, both are same. So this can be written as x greater than minus 4. So x greater than minus 4 using this principle. So therefore for real x, solution set is, now it is strictly inequality, so it will be in terms of open interval minus 4 to plus infinity. So this is the solution set in the case of x belongs to R. Now we take next example. Solve 3x minus 7 3x minus 7 greater than 5x minus 1. We have to solve in the case of real x. So solution, we have given 3x minus 7 greater than 5x minus 1. So first we add both side minus 3x minus 7 we have added both side minus 3x. So there is no change in the inequality. So now simplification is minus 7 5x minus 3x 2x -1, transfer -1 opposite side, or you can add +1 both the side. Let us add +1 both side. We add additive inverse of -1, that is +1. Add both side +1. So simplification is -6 greater than 2x. Now divide by 2. So when we divide by 2, therefore -3 greater than x. Again we use this basic principle, either we write a greater than b, or on the same time we can write b less than a, because here x is the variable and we are going to find solution for x. So this can be written as x less than -3. So x is less than -3, and therefore solution set is since inequality is strict inequality, so answer it will be in terms of open interval or real numbers which are less than -3. This side minus infinity, -3, -2, -1, 0, 1, all real numbers which are less than -3. So in this case solution set is open interval -infinity to -3. So this is the solution in the case of x belongs to R.